Hi, everybody. Happy Saturday. We're going to go through some of the problems here for this review for the Units 10 and 11 solo test. All right, starting off with finding the surface area of this here square-based pyramid. And in order to find the surface area, we need to know what this slant height distance is. We got the height of the pyramid is 15 and the base edge is 12. Well, the slant height is actually the hypotenuse of a right triangle formed by the height and 1/2 the base edge length. So that would be 6, half the base is 6, the height is 15, and we work that out to get the slant height as the square root of 261. It's about 16-ish. But I'm just going to leave it as the square root of 261. So the area of one of those triangular faces is the base times the height divided by 2. Since the base is 12, dividing that by 2 gives you 6. And so 6 times the square root of 261 is the area of one of those triangular faces. There are 4 of them, so we multiply that number by 4. And then this plus 144, that is the area of the square base, the bottom side, if you will, of the pyramid. That's 12 by 12, 144 square units. And so when you add all that together in its exact form, it just looks like this. 24 root 261 plus 144, and it's about 531.7. Okay, next one is a bunch of surface area and volume problems. These take a little bit, so feel free to slow down the video if I go too fast. The volume of a cone is 1/3 the base area times the height. You have to figure out what the height is. Again, with the Pythagorean theorem, you're given the slant height here and had to use that in a right triangle to find the height. It's about 16.58. You do all of this multiplying together and you get about 270.86 times pi, or about 850.9. The surface area is pi times the radius times the slant height is the area of the lateral area of the cone. That's the slanted sloping sides of the cone. So that little calculation right there gives you that. The base area is a circle, 49 pi, and you do all of this, you get about exactly 175 pi and about 549. So that's the surface area and the volume of that there. Cone, the cylinder right next to it, a little more straightforward perhaps. The volume is just the base area times the height, and that turns out to be 525 pi, which rounds up to about this area here, or volume, excuse me. And our surface area is the two circular top and bottom. That's 2 times 25 pi, since the radius is 5. 25 pi is the area of the top and the bottom, so 2 of those, plus the circumference times the height. The circumference is 10 pi times 21, that's 210 pi. So you add all that up, 260 pi for the total surface area, and about 816.8. Moving on to the other shape here, a cube with a cylindrical hole going through it. The hole has a diameter of 5 centimeters. The cube is a 10 by 10 cube. And so the volume is 10 to the third power minus the volume of the cylindrical passageway. And so the radius is 2.5, so 2.5 squared is 6.25 times 10 is 62.5. All of that times pi. So 1,000 minus that is about this number here, 803.65. The surface area is a little more complicated. We have to find the whole surface of the cube. That's easy. That's 6 times 100, since each face of the cube is 10 by 10. So that's 600. But then we have to also add in the internal surface of the cylinder, and that circumference times the height there is 50 pi. And but we also have to subtract the area of the 2 circular holes. So that's, it's 12.5 pi. It's 2.5 pi squared, or 2.5 squared, times pi. That's 6.25, but there are 2 of them, so that's 12.5 pi is the total surface area of those 2 circular regions that we removed. So all of that gives us this number right here when you do all the calculations. Okay. Let's move on to some of the counting problems. How many unique arrangements of the letters of the word unenpentium are possible? By the way, this is now called Moscovium. But anyway, before it was called that, it was called unenpentium, and there are 11 letters. There are 3 n's and 3 u's. So we have to take that 11 factorial and divide it by 3 factorial times 3 factorial. And you get this really large number, 1,108,800. How many different 5-card hands can be dealt from a deck of 52 cards? That's a lot of different possible hands you can get from a deck of 5 cards. It's simply a 52 choose 5, a combinations problem, since the order does not matter in a deck of in a hand of cards. So it's 52. This is the formula. If you work it out, most of your calculators could have this little thing programmed into it, and it's about 2.598 million. 960,000. Okay, let's keep going. On the back side, we got this problem about 3 similar pyramids, and you're given some information about them over here. This problem is about this ratio similarity R for the sides, R squared for the areas, and R cubed for the volumes, these ratios here. And their relationship. Anyway, the bases of the prisms are all equilateral triangles, and the lateral surfaces are rectangles. The volume of prism 1 is 1/27th that of prism 2. So the volume of prism 2 is 27 times the volume of prism 1. Okay, that gives you an idea there, right? If it's 27 times the volume of this little one here, then you take that's the ratio, 27 to 1. You can take the cube root of 27, which is 3, and that will be the ratio of their lengths. So it's the 3 to 1 in terms, 3 to 1 in enlargement from this one to this one, from 1 to 2, and that gives you a volume increase of 27 times. So the length of prism 2 is 30 centimeters, which is 1/2 the length of prism 3. Well, that's a pretty good clue. So that's 30, 1/3 of that is 10, and twice 30 is 60. So now, with that, we've got all 3 lengths of the prisms. The area of one rectangular face of prism 3 is 1,440 square centimeters. So if we know the length is 60, we can divide that into 1,440. And we get an edge length here of 24. 24 means that since it's an equilateral triangle, the height of that triangle is 12√3, and the area of that, and then we can calculate the area of all those bases. So you don't have it written down here, but so now we can do all the measurements or calculations that we need. What is the linear scale factor of prisms 2 and 3 relative to prism 1? So I've written them out here. Prism 2 to prism 1 is 3 to 1. Prism 3 to prism 1 is 6 to 1. And incidentally, prism 3 to prism 2 is 2. So prism 3 is twice as big as prism 2. If the height of one triangular base of prism 3 is 12√3, which we already figured out, what is its area? And that would be 144 times the square root of 3. That's the area of, where is it? This base right here, 144 times the square root of 3. Then finally, what is the volume of each of the prisms? Okay, so we can do this a number of different ways. I can go back, and if this is 12√3, this prism 1 here is only 1/6 of that. That would be 2√3. So I can figure out the area of that base is 4√3, and 4√3 times 10 gives you a volume for prism 1 of 40√3. Since I already know that prism 2 is 27 times this, I really only have to figure out what, multiply this by 27, and I get 1,080 times the square root of 3. That's the volume of prism 2. And doubling, since prism 3 is twice as long as this, that means the volume is 8 times this volume. 2 cubed is 8. So times 8, and there's our volume of prism 3. All right, so here's all the stuff once again for prism 3 if you need to stop the video and get a whole look at everything. All right, moving on then. Here are 45 runners enter the Fresno Marathon. A cash prize given to each of the first 4 people who finish. So that's 45P4. It's a permutations of 45 choosing 4. And the order does make a difference as they cross the finish line. So it's definitely permutations and not a combinations. This formula right here, if you need to work it out, a lot of your calculators will have this just programmed into it, so you can use that, or this little fraction, or just work it out this way. Anyway, you get 3,575,880 different ways for 4 people out of 45 to cross the finish line. Next problem. How many ways can 4 boys and 4 girls sit in a row of 8 chairs if they alternate girl, boy, etc.? Well, okay. So 4 boys is the way you can alternate or put 4 boys in order is 4 factorial, and same with the girls. And since we can have each of those, they would be multiplied against each other, with each other, excuse me. So that's 576 different ways that the girls and boys can alternate. However, there are actually 2 different ways this could happen. We could have a boy on the left end and with a girl on the right end, or we could have a girl on the left end and a boy on the right end. So actually, you take this number and multiply it by 2, and so you get 1,152 different ways that they can sit in those chairs. And finally, problem about 2 people arguing about how to arrange their debate club. How appropriate. Abby right, you be wrong. Are discussing a plan. Abby wants to have the club led by 3 officers, president, vice president, and secretary, but Yubi thought the club should be led by a 4-person committee. And a third friend of theirs, Obi Quiet, settled the argument by calculating the number of ways each of these arrangements could be achieved, and they all agreed that they should choose the higher number of the 2 different ways. So Abby is saying, let's do, out of 10 people, we're going to do a 10p3 calculation. That would be 720 different ways. Yubi was saying, let's have just the committee, so that'd be where the order does not matter. 10 choose 4 is 210, and so they agreed on the higher number, 720 different ways. They chose Abby's method of 3 class officers. There's your video. Enjoy. Bye-bye.